Hi there, welcome back to Weather Analysis with Mr. CB. So we're going to be doing some actual analysis in this video, to the best of our abilities because it is going to be a little bit difficult to see these graphics on here, but let's just go through some of these. So first, let's look at some QT log Ps and analyze what precipitation type we're going to have. So we're going to be using, sorry, this is a lot of text, but we're going to be using some of the things that we talked about in the past few videos to do this. It's a top-down approach. So the approach starts with seeing if there's enough moisture, or actually it starts with seeing if the sounding, any of it is in the DGZ, dendritic growth zone, which is from -12 to -18 degrees Celsius. Next, we're going to see if there's enough moisture to even have precipitation. We'll do that by checking the relative humidity. And then is any of the sounding above freezing? If it's all below freezing, then we can just expect snow to be likely what will happen. But if we have um, above freezing, is it a surface melting layer or elevated? Um, and then depending on what that is, you can see this all this right here, but we're going to talk about this, so I don't even need to say it right now. Oh, sorry, I just got surprised because my picture got dark for a second. But it does matter. But anyways, here's our first sounding. So what do we notice? So we're going to go through this and see some things. This data is very small, so I can hardly read that, but I have it typed on here what different things are. So part of the sounding is in the dendritic growth zone. Luckily on this, this is from BuffKit. You can see that these two lines indicate the dendritic growth zone, so that makes it a little bit easier. And yes, part of it's in there. So that means we do have potential for ice crystal growth. Um, is there an or there is an elevated melting layer? You can see it's not a surface melting layer because it goes back below freezing again. So it's an elevated melting layer. There is sufficient moisture because the green, which is the dew point, and the red are very close to each other. So we can know that precipitation can probably happen. Dendritic growth zone base is at 1,500 feet, okay? The max temperature of the elevated melting layer is 4.9 degrees. So we can look at this graphic right here to know what's going to happen to our ice crystal. So, well, it's greater than 3 degrees, so that's a complete melt. The thickness of the elevated melting layer is 6,500 feet. And if we go back to this slide, um, oh, that's total melting is going to occur. I should have put that on here too. So total melting is going to occur, complete melt. So complete melting is occurring. I just said that. The minimum temperature of the surface freezing layer is 2 degrees, -2 degrees Celsius. That is not enough for it to refreeze. Thickness of the surface freezing layer is very small too. So we can say, oh, one more thing is that this 2 meter temperature is -1 degrees. So the likely precipitation that we'll have is freezing rain. Um, that is because it is super cooled and then it's going to completely melt. But we do have a surface freezing layer that um you can see. I should have said this part. So it's -2 degrees Celsius. So that falls in this range. So freezing rain is likely going to be the case for this one. All right, now we do this one. Part of the sounding is again in the DGZ. There is an elevated melting layer once again. You can see it. There's sufficient moisture. Height of the dendritic growth zone is 17,000 feet. Max temperature of the elevated melting layer is again above. So we're going to have complete melting occurring. Thickness of elevating melting layer is 7,000 feet. That's pretty big. Complete melting is occurring again. Minimum temperature of surface freezing layer, though, goes down to -9.3 degrees Celsius. You can see that right here. It's very hard to see, but it's in the data right there. Um, So that is below 5 degrees. So sleet is actually what we're going to have in this case. That's why I put that yellow. So even though have a complete melt, it's able to refreeze with that temperature. So that's something important to realize. You have to look at multiple things, not just one thing. So this sounding here, what do you notice? Still part of it's in the dendritic growth zone. This time there's a surface melting layer because even at the bottom it doesn't go back below freezing. There is sufficient moisture. Um, Dendritic growth base 17,000 feet again. Um, Maximum temperature of surface melting layer is 6.6 degrees Celsius. Thickness is going to be 8,600 feet. So that is too big for there to be snow, so it's complete melting, and we have rain that's going to happen in this one. But if our surface melting layer was only 900 feet, like if it wasn't that big, then in that case, it would be snow. All right, right here, there's the elevated melting layer this time, but very shallow. So the max temp is just zero point 0.9. So that is less than 1 degree, so minimal melting will occur. Thickness is not that big at all. That says complete melting occurs. That's wrong. Sorry, it's minimal melting. I do copy and paste and I forgot to change it. Sorry. Surface freezing temperature. Okay, well, we go way down to 11.7, negative 11.7. Um, and so it definitely um is going to have a situation where we have partially. Okay. So sorry, I was trying to make sure that I was explaining it the right way, but we had because of this thickness, you might have thought this was going to be snow, but we actually that is enough thickness of the layer to cause partial melting, um, even though it says minimal melting for that. That's enough. So you're looking at multiple parameters here. And it it since it will partially melt, but it can refreeze right here from this, it's going to be sleet. Okay. This time there's no melting layer, it's all below, and that's easy to know. That's just snow. All right, now determining snow type, and what I mean by that is like light, moderate, or heavy snow, and then ratios. So this is Buff Kit again, but we have some other things that are shown here, and we'll tell you. So this is going to be a little bit trickier, but I'll explain it. Um, so what do you notice? There is sufficient moisture for snow, and all of these situations are going to be snow, by the way. Um, DGZ base is at 9,100 feet. So based on that, we might expect just based on that, we might expect low to medium um, snow to liquid ratio. And remember, if we have a low snow to liquid ratio, that's going to be wet snow. Um, but there's still more things that we have to look at. Max omega surface. So here are omega values up here, and we have negative 2.5 millibars per second um, omega. And remember, negative omega is strong uplift. Well, if it's the more negative it is, the stronger it is. No significant accretion or riming, which that means that we're above 5 degrees Celsius. If you look over here, that doesn't really happen. The greatest riming that we do have is the greatest temperature that we see, which is um -7.9, and then it occurs at 43,800 feet. 2 meter temperature is at 8 degrees. So the snow to liquid ratio will be about medium. Snowfall will be moderate in this case. Okay, this situation, we have sufficient moisture, of course. Then this time the DGZ base is at it's relatively low. It's at 5,500 feet right here. You can see from these values on the side. Not very strong omega values at all this time. Significant accretion or riming is occurring. You can see it um, work close to the zero line, which tells you that might happen. And you can see right here these values. Greatest riming, greatest temperature of riming is at -1.4 degrees Celsius. It's at 289 feet. 2 meter temperature is -2. So again, this is going to be about medium or moderate. So we went from low, but since we do have sufficient accretion or riming, um, that's going to cause it to be higher. All right, this one, DGZ base is a lot higher this time, -2.5 millibar per second omega, sufficient, significant accretion or riming based on these values. Greatest riming at -0.3 Celsius, 39 feet. So this is, well, that's kind of boring, but again, this is medium or moderate um, in this case. All right, this one, since we see all this purple right here, that is showing us that we have significant um, value of relative humidity. So we can expect there to be high precipitation in this one, I can already say. It's definitely sufficient moisture, pretty high DGZ base. So we might expect potentially higher um, ratio. But we do have a very strong omega value of -10. And then significant accretion or riming, greatest riming at 0.3 degrees Celsius. Snow to liquid ratio is going to be low this time. And snowfall, like I mentioned, is going to be high. But one reason why the snow to liquid ratio is low is because it's so close to this. The closer it is to this, the lower. All right, this time we have a low DGZ base, -5 millibar per second omega. No significant riming or accretion you can see because we don't get above -5 degrees Celsius. This is far away from it. So because it's far away from it, we could expect it to be higher snow to liquid ratios, and snowfall will be moderate. I'm kind of skipping through some of that because it's kind of the same thing. So that's it for this video. Thank you for watching.